Okay. So hello everyone. I am Ashish from IIT Ropar, India. So today I am going to talk about the formylation reactions of the quinoline molecules and the nitrobenzene molecules and their derivative. So in general, the formylation reactions took place by the use of a mixture of the CO and H2, and that too in a high pressure and temperature condition. But in the view of sustainability and the current energy demand, the entire world looks forward the alternative source of the current energy resources. So herein, what I'm trying to actually give a shadow on this topic, the sustainability. Here the formylation reaction was carried out using a formic acid as a sustainable source for the formylation as well as the reduction source. So for this, the particularly a catalyst design is very important in order to selectively activate the formic acids. So herein the zinc and cobalt embedded a ZIP, that is the zeolitic imidazole framework, a kind of metal organic framework group, and the integration with a covalent organic framework. That is, the COP is the mainly source for nitrogen and carbon. So further, in order to modify the carbon framework and nitrogen framework of the ZIP. So first the ZIP was the bimetallic ZIP, that is the zinc and cobalt with varying amount of metal concentration was prepared. Then the resultant COP ZIP material was carbonized in an argon flow in order to get the bimetallic embedded and doped carbon. So here you can see on increasing the or on in the presence of the COF, the nitrogen percentage and the nitrogen percents got increased because the COP actually the source for nitrogen as well as the carbon. So here we do not look into the carbon concentration, we only look into the nitrogen concentration, because the nitrogen presence actually holds the metal content, and adding the COP, actually the pyrolytic kind of nitrogen got increased, and that's why the pyrolytic kind of nitrogen has the ability to hold the metal atoms. Then after synthesizing this, the zinc metal actually this material was carbonized at 900 degrees Celsius, and zinc metal start to actually evaporate. So after the zinc evaporation, of course there is a small amount of zinc is left out. Then due to the evaporation of zinc, there are microstructure developed, or you can say the micropores develop. So it actually increases the total activity of the reactions. Then the obtained catalyst was systematically characterized to the various characterization techniques that includes the powder XRD, BET, Raman, and HRT. BET tells about the surface area where the maximum active sites distributed, and Raman tells about the kind of carbon material or the carbon structure present. So definitely you can see here on adding the COF. Actually, I'm actually herein I have just comparison of the two catalysts I'm talking about. One is with ZIP and another one is without ZIP. So in presence, sorry, with COP, and another one is without COP. So in presence of COP, the obviously the nitrogen was increased, as well as due to the more nitrogen, more defect carbon is generated. And you can see due to the defect carbon, the slight positive shift in the XRD also observed. Moreover, due to the presence of pyrolytic nitrogen and more number of nitrogen content, the cobalt, actually the cobalt nanoparticles that is developed upon the carbonization, that got completely reduced. Whereas in absence of COP, the slight surface cobalt get oxidized and it remain as a cobalt oxide, which is not good for the catalysis. And after this, the further this nitrogen content actually enhances the total basicity of these two obviously of these two materials, but out of which the CoF containing material has the higher basicity. And all we know that the higher basicity of the material is good for the formic acid adsorption. Then this is again further proved by the UV visible spectroscopy, where we can see the content of the nitrogen due to the presence of the nitrogen. This CoF material has the higher basicity, and due to this, it has the ability to absorb the uh, quinoline molecule more efficiently than the material obtained without the presence of CoF. After this, the catalysis of the formylation reactions, that is the N-formylation reaction, was carried out in presence of the formic acid and in aqueous medium solvent. We all know that even in the literature, so many literature report, the formylation reaction is a crucial step that is employed for develop the scaffold of chemicals for the various kind of drug molecules, food additives, and in cosmetic industry. So the importance of formylation reaction has always been there. So herein the formylation reaction was carried out in presence of the formic acid as a sustainable source. We all know that the formic acid can be obtained from the biomass derived carbohydrate. Any acid catalyst can valorize the carbohydrate and leads to the formation of the formic acid. So it is always been challenging and interesting to use such chemicals, use such green and sustainable chemicals for a purpose of chemical synthesis or for a purpose of this kind of nitroformylation or reductions. But here, in general, when we use the formic acid as the source for the reduction as well as the formylations, generally we obtain two kind of product. One is reduction product, one is formulated product. But getting a selective product is always crucial. We all know that. So for a particular product selectivity, you need a very precise kind of active sites. That's why all this kind of co-op addition, bimetallic additions came into the picture. So herein we can see when only non-carbonized material was used, the yield you can see the very low. 1B actually the formulated product of nitrobenzene, and 2B is the formulated product of the quinoline. These are the two model reactions, and their substrate scope has been carried out in this sections. When the uncarbonized material was used, a very low yield was obtained. And when obviously when the only alone CoF was there, it is also very low yield of this formulated product obtained, because formic acid may not be sufficiently activated here in this case. Similarly, when we use the only zinc atom, because after carbonation there is no zinc, very less amount of zinc is there, and obviously there is a micropores developed due to the evaporation of zinc. This gives 25% yield of this formulated N-formulated aniline, and it gives 18.9% of this N-formulated tetrahydroquinoline. So then when cobalt is there, the yield is slightly improved. When both these two metal atoms used, obviously here zinc content is very low, but it is significantly improved the activity. You can see here. And similarly, when the CoF is used in presence of zinc, what happens when CoF is used? It actually helps in modification of the carbon structure. It creates the defect in the carbon sector. It creates the metal holding center, that is the kind of nitrogen, and that also increase the activity comparison to its bare CoF containing. You can see here the entry number 3rd and entry number 6. Then when cobalt is used instead of zinc, it is also a good good yield of 1B and 2B. When both these metal atoms are used in presence of the CoF, it gives 86% and 83.5% of selective yield of the formulated product. That is quite good in kind of formulated reaction carried out when in presence of the formic acid. And the more important thing is this: the reaction, all these reactions are carried out in presence of aqueous solvent. at 130°C. So now, after all these reactions, we are so much curious how these reactions happening, what is the active sites, and why the reaction is carried out in presence of zinc and cobalt. But due to the space issue, I have not put the the decomposition of the formic acid, that is the TCD spectra of the GCTCD. What we got both kind of product, that is CO2, H2 as well as the CO in presence of zinc and cobalt. So that result actually not mentioned here. So that means the reaction pathway, when we compare the reaction pathway, then both the CO and CO2 were involved. One more thing is that we again went for the poisoning test. What happens? We put the KCN molecule. We all know that KCN molecules having the strong ligating effect that marks the metal center. When the KCN molecule we add, it actually decreased the activity. That means the metal centers are also active in this reaction. Further, we tested it for the hot filtration test. What hot filtration test means? During the reaction, at a certain time, we remove the catalyst and let the reaction to run for its original time, and we can see here that there is no improvement in the reaction happens. That means the reaction is only catalyzed through in presence of the catalyst. So keeping all these things, we deduce a mechanism where this is the active center of the mechanism. This is the graphical presentation. Zinc, cobalt are the active center. They are actually, zinc and cobalt are actually surrounded by the formic acid and your derivative, that is the reactant molecules, nitro or quinoline. They got adsorbed. And as I told you, in the GC spectra, we saw both the CO as well as the CO2. So when CO and CO2 are involved in a formylation reactions, there is a two kind of reaction pathways are involved, and that's known as the direct pathway and indirect pathway. In indirect pathway, the formic acid decomposition in such a way that the CO is formed and CO is participated in the formylation. CO is participated to get the formulated product. Similarly, in case of the direct pathway, first this nitro benzene is converted to its aniline, the hydrogenated product. Again, this aniline is react with the adsorbed formic acid to get a formulated product. As we got the two kind of decomposition product in the GC, that is the CO as well as CO2, hence we deduced two kind of pathway. And finally, the reusability test was carried out, where acceptable loss of the catalytic activity was observed, and then we can see that our developed catalyst is sufficient to catalyze the formylation reaction in presence of a sustainable formic acid as the source of hydrogen as well as the formulating source, and we avoid the use of poisoning CO and H2 or CO2 and H2. So this is all about my presentation. Thank you. And